Good afternoon, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yeah, we're talking about another space topic today, surrounding some things happening on the pink planet that have been discovered by the James Webb Space Telescope, which is our favorite telescope.
Not making this up, Pink Planet. I didn't even know they had a famous pink planet.
Did not know that.
James Webb uncovered exotic salt clouds surrounding the famous pink planet, which you see on your screen now. That's an artist rendition, solving a long-standing mystery about one of the coldest known alien worlds. Astronomers led by Northwestern University have uncovered an extraordinary feature surrounding the universe's famous pink planet. Skies filled with salt clouds. Would you like to know more?
For more than a decade, this ancient world, known for its rosy appearance, puzzled scientists. As one of the coldest planetary mass companions ever directly imagined, it is so faint that ground-based telescopes have struggled to analyze the light reflected from its atmosphere. New observations from the James Webb Space Telescope, however, have finally provided a much clearer view, revealing an atmosphere packed with universal chemistry or unusual chemistry and previously unseen salty clouds. Interesting.
Yeah, it's interesting. The findings provide some of the first direct evidence that salt clouds exist in the atmosphere of a cold planetary object, confirming an idea scientists first proposed more than 15 years ago. The discovery also demonstrates how James Webb Space Telescope is making it possible to study extremely cold, dim worlds that have remained beyond the reach of Earth-based observatories. The study was published on June 18th in the Astronomical Journal.
Okay, so I'm going to assume that in that picture, artist rendition picture, that is the sun in the upper right-hand corner.
Probably not our sun.
Oh,
Probably a star.
oh, okay.
Probably.
Because that's pretty far away from the sun, our sun.
Yeah.
So,
I
anyway,
mean, it doesn't say where it's located and what constellation, but what did it say? The sun?
I don't think so. I just assumed that because it was so bright. So, but you're right. Maybe it is a star.
Yeah.
Yeah. Okay, the pink planet is the coldest companion ever discovered using ground-based instruments. That's according to Northwestern's Anis Baba, Bab, Babaraj
Babaraj.
study. Quote, many teams all around the world performed follow-up observations to study its light, but it was too faint for ground-based instruments. That made it perfect for target for the JWST. When we finally obtained its spectrum, it immediately looked interesting. But once we started digging deeper into the data, we realized it was not like anything we have analyzed before. Ooh, it's a first.
Babaraj is an exoplanet researcher and postdoctoral. So if he's exoplanet, that means it's out of our solar system.
Okay, so that would not be our sun then.
Right. And postdoctoral associate at Northwestern Center for Interdisciplinary Exploration and Research in Astrophysics. He collaborated with scientists at the Space Telescope Science Institute, including Marshall Perrin, who designed the observing program for GJ504b. That's probably the star GJ504, and B means it's a second planet from the star.
Okay.
Perrin also serves on the JWST Telescope Scientist team, which helped develop the telescope and oversees its ongoing scientific operations.
First discovered in 2013, the pink planet, formerly known as JG504b, circles a sun-like star, there we go, located 57 light years from Earth.
That's close.
Okay.
That's close. Yeah.
All right. Despite its nickname, astronomers are still uncertain whether it should be classified as a true planet. With a mass roughly 25 times greater than Jupiter, wow, that's pretty big. JG504b lies near the boundary between giant planets and brown dwarfs. Because of that uncertainty, researchers describe it as a planetary mass companion, meaning a planet-sized object orbiting a star. Okay.
Its faintness has made the object especially difficult to study. While most directly imaged exoplanets have temperatures between 1,000 and 2,000 degrees Fahrenheit, GJ504b, or the pink planet, is only about 550 degrees Fahrenheit, comparable to the temperature inside a bread baking oven.
Hmm.
How nice.
Yeah, according to Babaraj, the object's relatively cool temperature reflects its age. Giant planets begin their lives extremely hot but gradually cool over billions of years. The team's analysis suggests that GJ504b is between 2.5 billion and 4 billion years old.
Yeah, not a big margin there. 2.5 billion and 4 billion, right?
Yeah, just a blink of an eye.
To examine the object, the researchers used JWST to capture its faint light while applying advanced data processing techniques to remove the overwhelming glare from its much brighter parent star. And remember, we've done this reporting before. They find out the properties when the planet transits across its star, and those light waves get bent by the atmosphere of the planet. Okay. That allowed them to isolate the companion spectrum, which separates light into different wavelengths. Because specific elements and molecules have unique fingerprints in a spectrum, scientists can determine the composition of an atmosphere by studying those patterns.
Quote, in the past, other astronomers observed the companion for an entire night with some of the biggest telescopes in the world to obtain a spectrum. And that's according to Babaraj. Going on with his quote, and they could not see the object. With JWST, our entire observation took around 2 hours, and we were successful. Wow.
That's cool.
Yeah.
Because that time on that telescope is limited. You got to wait in a queue, sometimes for years.
I was going to say, you got to kind of put it on a reservation, right? It's like,
yeah,
like a really good restaurant.
And prove that your work is valuable.
Yeah.
All right. The spectrum revealed an atmosphere containing water vapor, methane, carbon dioxide, ammonia, and several other molecules. When the researchers, I wonder if they know what the other molecules are. When the researchers compared these observations with atmospheric models, they encountered an unexpected problem. The models only matched the data by including unrealistic atmospheric conditions.
The mystery disappeared after the team introduced clouds into their simulations. Among several cloud types they tested, salt clouds produced by far the best agreement with the observations. Those clouds likely block the view of deeper atmospheric layers, changing that light that eventually reaches the JWST.
Quote, we ran simulations of clouds and the results aligned with what we know about cold planets, Babaraj said. We tried 3 different types of clouds and salt clouds fit best. When we accounted for salt clouds, it subdued the signature of molecules hidden deeper in the companion's atmosphere. Then the results became physically possible.
The observations also indicate that GJ504b contains an unusually large amount of heavy elements known to astronomers as metals. Even so, its origin remains uncertain. Based on the available evidence, it may have formed like a giant planet or more like a small star.
Babaraj believes the methods demonstrated in the study will help scientists investigate many other faint cold worlds. Jupiter, for example, is covered by clouds of ammonia ice. Although current instruments cannot yet study those cloud layers in comparable detail, the successful detection of salt clouds around GJ504b suggests that astronomers are steadily expanding what they can observe.
To end with a quote, this is the first time we've found that salt clouds are critical to explaining the spectrum of an object, Babaraj said. It's a good reminder to account for clouds in our models. So all I can say is my granddaughter would love this planet because she loves pink. So she'd have one hanging in her room if she could. So there you go.
Maybe we'll name it after her. Maybe.
Yeah. GJ504b Ava. Yep.
All right, folks. Thanks for joining. We really appreciate it. We'll see you tomorrow.
Yep. Take care, everyone. Have a great afternoon. And we'll see you tomorrow.